My name is Todd Habakoff, Senior Performance Consultant with IntelliMagic. MLC software costs typically represent the single largest component of the budget for mainframe installations. I'd like to show you the kind of visibility IntelliMagic Vision will provide into your environment to identify possible MLC reduction opportunities for you when you choose to participate in our no-cost MLC assessment. This chart displays cycles per instruction, the number of machine cycles spent executing your business instructions in your environment. The red line at the top represents the total cycles per instruction. The distance between the red line and the blue line are the productive cycles, the cycles spent actually executing your business instructions. The space below the blue line are the unproductive cycles spent waiting for data and instructions to be fetched into level 1 cache so that they can be executed. As a metaphor, think of being in a taxi. You're driving down the road, the meter's spinning, meter's running, everything's fine. Then you run into a traffic jam and you are just sitting there. The meter's still running, but you're not getting anywhere. That's what's going on for the distance below the blue line here. And that is the focus of efforts to improve processor cache efficiency to reduce those unproductive waiting cycles. Fortunately, IBM provides a metric that correlates very closely to that, and it's RNI, relative nest intensity. So here we'll pull up RNI for the systems in this environment and zero in on one in particular. So this is a relative nest intensity for this interval. Now, in this environment, a change was made that increased the number of vertical high CPs in the vertical CP configuration managed by HyperDispatch. We advanced to that time interval after that change was implemented. And now we'll compare the values from that new interval to the previous interval. And you can see that relative nest intensity, RNI, decreased significantly, over 20% in this environment as a result of this change that increased the number of vertical high CPs where the work is executing and which does not experience cross-LPAR contention for processor cache. We zero in on the RNI biological processor, and we will edit out the zip CPs. We're only interested in the general purpose CPs here. We can see that on the left before the hardware change, these two logical CPs that were vertical mediums and were experiencing cross-LPAR contention for processor cache from other LPARs had RNIs that were significantly higher than the 3 vertical highs. In the after configuration, all 5 CPs are vertical highs, and we can see that we had a very significant improvement in RNI, particularly for the CPs that went from vertical mediums to vertical highs. So having as much work execute as possible on vertical highs is a very important way to improve processor cache efficiency. And so IntelliMagic Vision provides several charts that help provide visibility into that. This is the amount of work that's executing on vertical highs by processor. So we can see then where the opportunities are, where is the most work that's not executing on vertical highs. This is when we can drill down on this on a processor and see the MIPS by polarity over the time interval. So this is how many MIPS we're executing on vertical highs in yellow, vertical mediums in blue, and vertical lows in red. Also, IntelliMagic Vision provides insight by LPAR. So again, we can see where are the biggest opportunities to try to have more work executing on vertical highs where it'll experience improved processor cache efficiency. Another important aspect of MLC reduction is to manage the peak 4-hour rolling average, the monthly peak for the month, because that's what the bill is based on. So it's very important to be able to understand the work that's running at that time so that you can see if there are steps you can take to reduce the peak, reduce how much higher the peak is than the other intervals during the billing month. And actions that can be taken may involve capping, or it may involve rescheduling some of the work that's running at the monthly peak time if it can run at another time, or reducing the rate CPU consumption of some of that work at the peak time, again trying to flatten out the peak. So understanding the work that's running at the peak period is a very important aspect of MLC reduction, and IntelliMagic Vision gives you great visibility into that and great flexibility in doing that kind of analysis. So let's drill into this processor. The rolling 4-hour average is still here in red, but now the RMF interval CPU consumption is in blue for each RMF interval. So we can see that it was the surge in workload during this time period that drove the 4-hour average to its peak for this interval. So then we can drill into that and see, okay, what work is running then. We have, here's the by workload as defined in the WLM policy. And we can say, well, maybe there's more batch running here during this peak period, monthly peak, than I'm used to. So we want to drill into that, and we drill in by system. You can see that most of it is running on this system, and so we can drill into that by, say, service class, see what service class it is, and we could drill in below this by address space as well. So IntelliMagic Vision gives great visibility into what work is running during your monthly peak period, so that you can see if there are actions you can take to reduce the size of that peak. So when you participate in an MLC assessment, we do all that kind of analysis on your data and provide you that kind of visibility into your environment to see what kind of MLC reduction opportunities there may be in your environment. So if you're interested in learning more about reducing MLC, go to this website and reach out here to express interest in having an MLC assessment done with the data in your environment.